Okay, today we're going to talk about the properties of density. So density is how much stuff is in a given area. A good example of density would be if we put 10 pair of jeans into a big duffel bag, or that would be less dense than if we put 10 pair of jeans in a purse. Because if we put 10 pair of jeans in a purse, they would be really tightly packed in there, and that would make it more dense. So what is more densely populated, Onega or Topeka? Erica?
Topeka, because it has more people per square mile.
Right, there's a lot more people in a given area than there are in Onega. So we're going to do a little lab with liquids to show you density in a jar. So we're going to have vegetable oil, honey, water, and dish soap. We're going to put it in layer by layer. And I want you to come up here to the board and write a prediction about what you think will happen. Erica, do you want to go first? Okay. Do you want to go too, Jessica?
Yes. Choose a different color. Yeah.
Okay. So we're going to try it out and see if what you predicted was correct. First is honey. And then we'll do some dish soap. And then water. And oil. So here are little examples of what will happen in your own jar, so you can see it close up. So there's a few that are incorrect, but you guys were close. Erica, you were right, honey is on the bottom. And then next is the soap. And then we have water, and then oil. So oil has the least density of all the liquids, so that's why it's at the very top. So what we're going to do next is we're going to make some more predictions, and you're going to write a hypothesis for if we put a bead in the solution, a paper clip, a bean, and a straw. So I want you to think about those a little bit and write them down, and then we'll share them. Make sure you write your hypothesis in an if-then statement. So for example, if I place a bead in the jar, then you write what you think will happen. Okay, Erica, do you want to share your hypothesis for the bead?
I think that if I place a bead in the jar, then it will sink to the bottom.
Okay, let's try it out. So it doesn't go all the way to the bottom, it stops right before the honey. So it's not heavy enough to get all the way through the last layer. Jessica, what do you think will happen if we put a bean in the solution?
I think the bean will sink to the bottom below the honey.
Okay. The bean does the same thing as the bead. It stops to the top of the honey. So nothing has gone through the honey yet. What do you think will happen with the paper clip?
Think it'll go? Maybe.
Okay, we'll see if it'll go all the way to the bottom. It does. Can you see it moving through the honey?
Yes.
So what will happen if we put a straw? Where will that go?
Under the oil, but on top of the water.
You think it'll go under the oil? It doesn't. It stays at the top.
Gee willikers.
So what object is the least dense?
Straw.
Straw.
And what has the most?
Paperclip.
Right. So think about how this would work in our atmosphere and in our weather. How does that work with our air? How does density work?
Well, I guess since hot air rises and cold air falls, then cold air would probably be less dense. Or more dense. I meant,
More dense, yeah.
not bad.
The cool air will sink and the warm air will rise, and so it'll cause convection currents, and the wind and heat will move through the troposphere, and that's how it happens with density. So if we didn't have if density didn't work like this, then that wouldn't happen. Do you have any other questions?
How does that work with like population density?
Okay, if we had a pond, and there was two of the same size ponds, and one had a few fish in it, and the other one had hundreds of fish in it, what would happen? What would those fish have to do?
They would have to like compete for resources.
Right, there's not enough space for all of them to live in there, right? If there was just 3 fish living in a pond, they would have a lot of room and they would have a lot of resources. But 100 fish, that would take up more space. So that would be more density. So more density isn't necessarily a good thing, right?
Right.
What about people? Like, does it same with people with resources?
Yeah, it works the same. Just like we talked about the example of Onega and Topeka. What's the difference between those 2 cities?
And Topeka is just more populated, so there's more.
It's like
Would that-
diseases.
Yeah, would that work with diseases? Like, if there's so many people packed into an area,
Yeah.
and then one person gets a bad disease, then it could spread.
Yeah, if the
easier.
density of people was greater, then they would have a lot more chances of getting a disease and other sicknesses. So what would happen if, why don't you think about maybe some other objects we could put in here that would stop at each level? Could you write a hypothesis about that? You pick any object.
Like
And
a
right-
ping pong ball?
Yeah. We didn't get anything to stop at the water. So what is your idea?
If I place a ping pong ball in the jar, it will float on the oil.
Yeah, and you're right. A ping pong ball is very, very light, so it would stay at the very top and probably wouldn't go through any of those layers. It would stay at the very, very top. Erica, what ideas do you have?
I think that if you put a pop bottle in, then it will float on the top of the oil because it's less dense.
You're right. So to further this experiment, if we wanted to expand and learn more about density, we could make a bigger solution and we could try different objects in it, and then we could test what has more density than some objects. So if a density, or if an object is really, really big, does it necessarily have, is it more dense than an object that's small?
No, because you could have like a metal ball the size of a ping pong ball, but that would be more dense than like a huge ping pong ball that would be like a regular, almost like this
Right.
one,
Because density is related to mass and volume.
not size.
Exactly, not so much size. All right, so tomorrow maybe we'll try to make more solution and we'll try more objects to see what happens and we'll test your hypothesis.